Hi. In this video, I'm going to show you an example of how to solve a system of two linear equations with substitution. Okay, so here we're asked to solve a system of equations with substitution. And here's the system. 3x plus 2y equals 10, and 2x plus y equals 6. So the way we started last time in the first video on substitution is we had one variable in one of the equations that was isolated. I think we had y equals something. And in this equation, this system of equations, we don't. So what we're going to do first is we'll isolate one of the variables, and then we'll substitute it into the other equation, and then we'll figure out what the variable left is equal to, and then we'll substitute that back into one of them and figure out what the other one is equal to. Then we'll have the solution, and then we'll substitute back. We'll just do a check by substituting back in. Okay, so again, I'm going to number these. I'll call this 1 and 2. And so we need to isolate one of the variables. And this is one of the things you need to write as you're doing. Explain what you're doing. Isolate, and then you'll either usually say you're isolating x or isolating y, and then explain which equation you're doing it in. So we could isolate any of these, but the easiest variables to isolate are anywhere the coefficient is 1 or -1. For example, if we wanted to isolate x in the first equation, we could subtract 2y from both sides, but then we'd have to divide by 3. And we're more likely to run into things like fractions if we do that. But there's one variable in one of these equations, and it's this one right here, where we can just isolate it in one step just by subtracting 2x, and we'll just have y equals something. So if you're looking to isolate a variable, look for one somewhere that has a coefficient of 1 or -1. So we're going to isolate y in equation 2. So right now equation 2 is 2x plus y equals 6. And I'll subtract 2x from both sides. And that gives me y equals 6 subtract 2x. This is what we're going to use to substitute into the next equation. So this is an important equation, but it really is just equation 2 but rearranged. So I'm going to give it a name because I want to be able to refer to it, but just to show that it's the same as equation 2 but rearranged, I'm going to call this 2 prime. So that's just a little apostrophe, but to read it you say 2 prime. Okay, so I've got a variable isolated, and now I'm going to substitute this into the other equation. So I'm going to substitute 2 prime into. Now, if I substitute it back into 2, I'm going to run into problems. You can try that. It's interesting to see what happens, but I won't be able to find an answer. So because this is equation 2 here, to get an answer, I have to substitute into the other equation. So I'm going to substitute into 1. So equation 1 was 3x plus 2y equals 10. So now I'm going to replace my y with 6 minus 2x. So I have 3x plus 2 times 6 minus 2x equals 10. Now, this is a good stage to be at because I have a linear equation and it only has x's in it. So I'll be able to solve that without too much trouble. So I have 3x, I'll multiply this thing by 2. So I've got plus 12 minus 4x equals 10. If I combine my x's here, I have negative x plus 12 equals 10. Then I'll subtract 12 from both sides. Negative x plus 12 minus 12 is 10 minus 12. So I get negative x equals -2. And then I'll divide by -1 to get x equals 2. So that right there is pretty important. I'm going to give that a number. The biggest number I've used is 2, so this will be equation 3. So that's a great sign there. So now I have an actual value for one of the variables. So at this point, all I have to do is take this x value, x equals 2, and sub it into either one of the equations, and I'll get the value of y. So it's important this first time when we isolate a variable, we've got to substitute that expression into the other equation. So we isolated it in 2, we have to substitute it into 1. But down here, now that we've got an actual number for one of the variables, we can substitute into either one, whichever. So either one of them would be fine. I guess I'll substitute number 3. Oh, notice that when I'm calling the equations by numbers, I always put them in circles. And that's just because if you don't put them in circles, it's really easy to just think that it's just a 2 and it's part of your equation. And you can make some really silly mistakes. So it just takes an instant and it'll reduce the chance you make silly mistakes. Okay, so I'm substituting number 3 into, I could do either one. I guess I'll do equation 1 just because it's first. So equation 1 was, equation 1 was 3x plus 2y equals 10. And so I'm just going to replace my x with 2. So I have 3 times 2 plus 2y is 10. So 6 plus 2y is 10. I'll subtract 6 from both sides. 2y is 4. So y equals 2. So there we go. We have the solution. We still have to check it because it's so easy to make a little mistake and all of that. But the solution is, I'll write this in pink. xy equals, oh, and they're both 2. So x is 2 and y is 2. Okay, so over here I'll do a check. So in equation 1, my left side equals 3x plus 2y. So that's 3 times 2 plus 2 times 2. So 6 plus 4, that's 10. The right side also equals to 10. Perfect. Left side equals right side. Okay, for equation 2, my left side is 2x plus y. So that's 2 times 2 plus 2. So that's 6. And the right side, oh yeah, good, is also equal to 6. So left side equals right side. So because we found the values of x and y, that if we substitute in both of the equations are true, this is the solution to the equation. If we were solving this graphically, we graph these two equations and see where they cross each other, which would be at the point 2, 2. So the solution to this equation is the point 2, 2. Okay, good luck.